Now it's time to review our unit on exponential and logarithmic functions. The first thing we talked about was the definition of log, which is really asking what power of your base gives you a certain exponent, and or gives you a certain answer rather. So the first thing we learned to do was rewrite things from log form into exponent form or vice versa. So what we want to remember is that you have log of your base, so in this case it's going to be my base is 2 to the h equals x. If I don't see a base and it says log, that means my base is 10. So this would be 10 to the y equals b. Then we're going to go the other direction. I have an exponential function, and I'm going to write it as a log. So log base e of d equals 4. And remember, the d is called your argument, and it's larger than the e. The e is a subscript. And then for this one, we need to remember that log base e is really natural log. So natural log of d equals 4. Last one, log base 4 of 6 equals f. Okay, so when I'm evaluating, we're asking what power of 5 gives me 125, and the answer to that would be 3. What power of 36 gives me 1 over 6? Okay, that one I don't know off the top of my head, so what we want to do is rewrite things in terms of the same base. So I'm going to rewrite 36 as 6 squared to the x, and on the right side, I'm going to rewrite that as 6 to the negative 1, and now I can solve their exponents. If the bases are equal, that means their exponents need to be equal. So I'm going to solve the equation 2x equals negative 1, so x equals negative 1 over 2. In the next one, if I don't see a base, it's really I don't see a base and it says ln, that means natural log. So e to what power is e to the 4th? Just 4. The other way to think about it is that natural log and e are inverses, so they undo each other, and I'm just left with my exponent. The next one is saying, what power of 7 gives you 0? Well, nothing will give me, no power is going to give me 0, so that would be no solution. Then we have log of 100. It doesn't have a base, which means its base is 10. So 10 to what power gives me 100? 2. The next one, this is saying log base 3 of negative 3. So what power of 3 gives me negative 3? Nothing is going to make that turn negative, so that's no solution. What power of 16 gives me 4. Now, if you know a shortcut for this, then that's great. But if not, here's what we can do. We can rewrite 16 to be in the same base. So 4 squared, and then do what we did in the other problem. Equals 4 to the 1. So 2x equals 1, and x equals 1/2. The shortcut is to know that if I'm doing the square root to go from the base to the argument, then I am doing it to the 1/2 power. Okay, you don't want to put 1/4 because this isn't division. It's saying what power of 16 gives me 4, which would be 1/2. And last one, 2 to what power gives me 1? And the answer to that is 0. All right, then we looked at log properties where we either condensed, aka got smaller, or expanded. So what we want to do first is deal with any coefficients out front before I do anything else. So if I have that 3 out front, it comes in as an exponent. And so my next line would be natural log x minus natural log y cubed. And now I have subtraction in between my two logs, so I can combine that by division. X divided by y to the 3rd. So when I look at the next one, we want to start with what's inside parentheses. So inside parentheses, I have log x plus log y. I'm combining the same bases. Both of them are base 10. So I'm going to squish those together, and that's going to be log of xy. Then, like the previous one, we want to bring in any coefficients as an exponent. So this would be log of x minus 4 minus log of quantity xy to the 4th. And now I have subtraction between my logs. So I'm going to combine this into one log with division. So in the numerator needs to be x minus 4 over xy quantity to the 4th. And that all is in my argument. I have one log. That's what it means to condense. And the important thing is not to split up this x minus 4 in the numerator anymore, because there's not a log in front of that 4. That whole thing is the argument, so I can't split that up when I'm condensing. All right. So now we're going to go in the other direction. So for this one, we're going to start with the fact that we have division in between. So I'm going to have subtraction when I break this puppy up. So log base 5 of parentheses x minus 4 minus log base 5 of square root y squared minus 25. So this first thing with log base 5 of x minus 4 is actually done. I can't do anything else with it on the inside, because on the inside I don't have any exponents or multiplication between my things on the inside. So now what I want to do is, you need to remember that something that has a square root is really the same thing as having it to the 1/2 power. So I can think of this as to the 1/2 power, which means now I can bring it out in front. So log base 5 of x minus 4 minus 1/2 log base 5 of y squared minus 25. What I'm left with on inside is connected with subtraction, so I can't split it up anymore. That's my answer. Where we were getting into trouble was continuing to split that up. All right. So the next one, I want to start with the fact that I have x and y here, and they're attached with multiplication. So I'm going to split that up first and make it natural log y cubed plus natural log 5th root of x squared. And now I have exponents with both of these that can come forward. And what you want to remember here is the whole power over root thing when we get to x. So 3 natural log y plus power is 2 over root is 5 natural log of x. After properties, we talked about solving. To solve, we had to, if it was exponential, we would get our base by itself. So my two steps to do that were to minus 4, so 2 to the 6 x minus 3 equals 20. Divide by 2, so 6 to the x minus 3 equals 10. And now we're going to rewrite this as a log, like the first thing we did in the video. So that would be log base 6 of 10 equals x minus 3. Okay, and we need to remember how to type that in the calculator unless you have a specific function. That's going to be log of your argument, which is the, I'm going to say top, it's not really top, but top number, divided by log of your base. So in this case, log 10 divided by log 6. Some of you have a function on your calculator that you can just type it in, which is really cool. And then after I get that answer, I'm just going to add 3. So when I do log 10 divided by log 6, I get 1.285. and then I'm going to add 3, so I get x equals 4.29. Remember, in the problem, always keep it more exact than what you want at the end. The next one, we're going to treat the same. My base this time is e. So subtract, my 2 steps to get e by itself are subtract 5. So negative 3e to the 7x equals negative 12. Then divide by negative 3. So e to the 7x equals 4. And rewrite it as a log. So log base e of 4 equals 7x. But log base e is just natural log. So I'm going to do natural log of 4 equals 7x, which means after I do natural log 4, I'm going to divide by 7. So natural log 4 is 1.386. And then we'll divide by 7. And that gives me approximately 0.2 when I round to the hundredths place. Okie dokie. Then we had this monstrosity over here. So this one is more annoying because you have an exponent on both sides and not a common base. So the first step here was different than the other ones, which is that we want to take the log of both sides. So I'm going to do log. So log of 2 to the 3x minus 4 equals log of 5 to the 6x minus 7. One thing that was confusing some of you is you were treating the base as 2 or the base as 5, but really it's a base of 10. I'm doing log. Now I could do natural log of both sides, which actually when I was a student is what I did because it was one less letter to write. Yes, I was that lazy. And the reason that this is helpful is now I can use my log property and move forward my exponent. So I can say 3x minus 4 times log 2, once again that's an argument of 2, not the base, equals 6x minus 7 log 5. And now we're going to distribute. So when I distribute, I get 3x log 2 minus 4 log 2 equals 6x log 5 minus 7 log 5. The next goal is to get all the x's on one side. So I'm going to leave the 3x over there and subtract the 6x. And then get the non-x terms to the other side. So I get 3x log 2 minus 6x log 5 equals 4 log 2 minus 7 log 5. The whole point of moving that over is now everything on the left has an x, so I can factor it out, which leaves me with 3 log 2 minus 6 log 5 equals all that junk. I guess I won't be lazy and just do what I normally do, but there we go. We'll write it out. Almost have enough room. Okay. And finally, we're going to divide by all that junk in the parentheses on both sides. Now, when we type this in the calculator, you need to make sure you have a stinking ton of parentheses. Otherwise, things aren't going to go well in the land. You need to have parentheses around the numerator, the entire numerator, and the entire denominator if you're trying to do this in one fell swoop in the calculator. And when I do all of that on the calculator, I get that x equals 1.12. So that was solving exponential equations. We also looked at going the other way and solving logarithmic equations. So to do this, we need to get our log by itself. So in this case, my two steps to solve and get my log by itself are minus 5. So 2 log 3x minus 1 equals 2. And then divide by 2. So log of 3x minus 1 equals 1. After we get the log by itself, we're going to rewrite it as an exponential. This one I don't see a base, which means that it's a base of 10. So 10 to the first power equals 3x minus 1. And in this case, I don't really need to simplify my 10 to the first power. It's just 10. And then we're going to solve for x. So add 1 would be 11. And divide by 3. 2 steps. This next one was our favorite because we didn't have one log, which is my goal. So what we need to do is use our log properties and condense this puppy first. Since my two logs are connected with addition, we're going to combine them into one log, so log base 2. And addition means that we're going to multiply the arguments together. Equals log base 2 of 10. Now, since both sides are in terms of log base 2, I can set their arguments equal to each other. And I'm going to be a little lazy and go ahead and distribute that first part. So x squared minus 3x equals 10. And now we're going to solve, hopefully by factoring. This one does factor, yay! But we're going to solve by factoring. If factoring doesn't work, then we can always quadratic formula anything in the world. That's a quadratic. So what two things? Multiply to negative 10, add to negative 3. That would be negative 5 and 2. So x minus 5, x plus 2 equals 0. And when we solve that, we get x equals 5 or x equals negative 2. With these, we need to check and see if that makes any of my arguments negative. So if I plug in 5, I get 5. 5, I get 2, so that one's good. But when I do it and plug in negative 2 to my first log is going to be negative as well as my next one. So my only solution for this problem is 5, not negative 2. The last thing we looked at with exponentials and logs was finding inverses. So for finding inverses, it works the same way whether I'm dealing with an exponential equation or a logarithmic. You're trying to get something by itself and then using the inverse. So if it's exponential, I'm trying to get the exponential by itself. And I got so ahead of myself that I didn't do the first thing for finding inverses, which is what? Switch x and y. I'd probably get to the very end and be like, oops, let's just go fix everything. All right, now we're good. So we want to get the base of 3 by itself. So my two steps to do that are minus 7 divided by 2. So x minus 7 divided by 2 gets my base of 3 by itself. Once it's by itself, we use the first thing we did in the video, which was to rewrite it as a logarithmic equation. So log, what's my base? 3 of x minus 7 over 2 equals y minus 4. Y'all, if you're stuck, think about it. I can't just randomly keep these two things that were already together. Like I have a lot of people writing it with blue, red, green instead of blue, green, red. Okay, they have to switch spots because I can't just like randomly throw a log in there and everything else stay the same. All right. And my last step there would be to add 4. So I'm going to get log base 3 of x minus 7 over 2. Wow, that was a horrible 2. 2 plus 4. Another pro tip is look at your starting equation. I had times 2, and what do I have at the end? Divide by 2. I had an exponential base of 3, so I have a log base 3. I have a minus 4, so at the end I have a plus 4. I have a plus 7, and somewhere I have a minus 7. You should have all those inverse operations in your final inverse if you do it correctly as a way to just kind of check to make sure you did it all right. Okay, so I'm not going to forget my first step, which is to switch x and y here. Now, this time we want to get the logarithm by itself. So we are going to add 6 divided by 5. So x plus 6 divided by 5 equals natural log of 3y minus 2. I don't see a base, and it's natural log, which means my base is e. So now I'm going to rewrite this as an exponential function. So e to the, what? X plus 6 over 5. Because it can't be what was with e already, which was 3y minus 2. They need to swap. And then my last two steps to get y by itself are to add 2 and divide by 3. So e to the x plus 6 over 5 plus 2 divided by 3. And we can just leave it like that for now.